This is the lab for target costing. As a simple explanation, target costing is a system under which a company plans in advance for the price points, product costs, and margins that it wants to achieve for a new product. If it cannot manufacture a product at these planned levels, then it cancels the design project. With target costing, a management team is a powerful tool that continuously monitors products from the moment they enter the design phase and onward throughout their product life cycles. Before we begin, remember to format the entire spreadsheet to currency with no dollar signs and 0 decimals. Now, for our problem, we are manufacturing widgets, and the company has 2 possible locations they can use. Because of tax breaks given to them, they expect to make 170,000 widgets if they select Site A and 190,000 widgets if they select Site B. The company expects to make these widgets before seeking additional tax breaks or changing to another location. The cost data is shown here. You can see that the fixed costs are broken up into categories while the variable cost is only given per widget. Of course, you can see where I changed the formatting to 2 decimal places and or added dollar signs. The company requires a return of 19% of the market price of the widget. You can see that I formatted these cells for percentages. But if you look closely at the entire image, all the cells are in alignment. That doesn't happen if you mix your formatting with the dollar signs or the dollar icon and other formats. For the first computation, if the current market price is $6.10, what is the target cost per widget? Well, we know the company requires a return of 19% of the market price. So the target profit should be 19% of $6.10. Then, if the target cost is the target price less the target profit, and as we just said, the target profit is the required rate of return times the market price, then the target profit is $1.16 and the target cost is $4.94. For the next computation, we'll work on determining which site should be opened. Our first step is, given the market price, what is the cost per widget at each location if the fixed overhead costs are assigned to products based on the estimated number of widgets that will be manufactured. To do that, we need to determine how much overhead we have to allocate per widget. We know that the fixed overhead is allocated based on the number of widgets, so we have a simple math problem. Here, you see the total fixed cost and the total widgets. Dividing the cost by the number of widgets gives us the cost per widget. Site A has a fixed cost of $2.74, and Site B has a fixed cost of $2.31. Of course, that's per widget. Then we need to determine the total cost. We were given the variable cost in the initial data, so we just add the fixed cost that we just calculated. You see that Site A has a total cost per widget of $5.04. That is a problem because the target cost is $4.94, so we shouldn't use Site A unless something changes. Site B has a total cost per widget of $4.21, and that's a lot lower than the target cost per widget. It may be as good as the data states, but in real life, I double-check my data because that is almost 20% less than our target cost. In real life, we should know why there's such a difference before we go ahead and proceed. Now we can figure out which site should be open. Since only Site B has a cost less than or equal to our target cost, that's the only site to which we should open. Now, since we know that Site A isn't viable, let's say the engineers were asked to look at the system again. This happens a lot since the tax breaks for A are valuable and may be more valuable than B. So the engineers determined a new machine could help reduce the variable cost. But that's going to change costs. The machine will cost $15,000 and the remediation cost will increase by $5,000. So we have to redo our analysis. Redoing the work shows the fixed cost allocation is now $2.85 per unit. Remember, this number includes the increase in the remediation work of $5,000 and the cost of the new machine of $15,000. So total expenses are $20,000 higher than our first analysis. Fortunately, this gives us a total cost of $4.90. That's less than our target cost. So with the new machine, Site A becomes a viable option. Now both sites are viable, and management can continue its analysis. That's it for this lab. Please let me know if you have any questions.